Understanding Grading Fundamentals in Civil 3D, created by Ahmed Dmour. Welcome to this lesson. Before working with any grading tools in Civil 3D, it is essential to build a clear understanding of what grading actually means from engineering and software perspective. Many users jump directly into commands such as grade to surface or create grading without fully understanding what is happening behind the scenes. As a result, they can produce geometry, but they often struggle to control it, modify it, or troubleshoot problems when the design becomes more complex. What is grading? In civil engineering, grading refers to the process of shaping the ground surface to meet the specific design requirements. This includes creating slopes, leveling areas, connecting road to terrain, and ensuring proper drainage. In Civil 3D, grading is the process of generating a designed surface by projection from a defined boundary toward a specific target using controlled rules. This means grading is not just drawing lines or slopes, it is a system that calculates how the surface should be formed based on the design criteria. What does grading actually do in Civil 3D? Grading in Civil 3D creates a relationship between three main elements: a starting boundary called the footprint, a set of rules called grading criteria, a target such as a surface or elevation. From these elements, Civil 3D generates a three-dimensional surface that represent the final ground condition. Core components of grading. To understand grading clearly, it is necessary to break it down into its main components. Every grading object in Civil 3D consists of four key elements. The first component is the footprint. This is the starting line or boundary from which the grading begins. It can be a feature line, a parcel boundary, or even the daylight line from another grading. The footprint defines where the design starts. The second component is the projection line. This represents the path along which the grading extends from the footprint toward its target. It's controlled by slope or distance. The third component is the daylight line. This is the point where the grading meets its target. Usually the existing ground surface, it represents the end of the grading projection. The fourth component is the grading face. This is the surface area between the footprint and the daylight line. It represents the actual graded surface and it's usually displayed with a center marker. Understanding these components is critical because every grading operation you perform is built from this structure. Understanding grading target. A grading operation always requires a target. Without a target, Civil 3D doesn't know where the grading should end. There are several types of grading targets available, and each one serves a different design purpose. The most common type is a surface target, where the grading extends until it meets an existing ground surface. This is typically used when tying a design into natural terrain. Another type is a distance target, where the grading extends a fixed horizontal distance from the footprint regardless of elevation. A third type is a fixed elevation target, where the grading stops at a specific elevation value. Finally, there is a relative elevation target, where the grading is defined relative to the elevation of the footprint itself. Each of these target types allows for different design strategies. It's essential for achieving the desired result. The role of grading criteria. Grading doesn't happen randomly. It is controlled by a set of rules known as grading criteria. Grading criteria define how the grading behaves. This includes parameters such as slope, target type, and projection method. When you create grading in Civil 3D, you are essentially applying predefined set of criteria to a footprint. For example, criterion might be slope to surface at 2 to 1. This tells Civil 3D to project from the footprint at a slope of 2 horizontal to 1 vertical until it intersects the target surface. Grading criteria are what transform a simple line into a control engineering solution. The importance of feature lines in grading. Feature lines play a central role in grading. In most cases, the footprint of a grading is a feature line. A feature line is a 3D object that contains elevation data and represents a physical boundary in the design. Unlike a simple polyline, a feature line can control slopes, elevations, and grading behavior because grading depends on the accurate starting geometry. Feature lines are considered the backbone of the grading design in Civil 3D. Grading and surfaces. One of the main goals of grading is to create a final surface. When grading is created, Civil 3D can automatically generate a surface from the grading group. This surface represents the finished ground and can be used for visualization, analysis, and volume calculations. It's not only about shaping geometry, but also about calculating cut and fill, evaluating design visibility, and optimizing earthwork. Grading groups. Grading objects are not created individually in isolation. They are organized into grading groups. A grading group is a calculation of grading objects that are combined to form a single surface. This grouping allows Civil 3D to manage multiple grading elements as one system and compute volumes accurately. Before creating grading, it's important to decide how grading groups will be organized because they directly affect surface creation and volume analysis. This means grading is part of the topology system discussed in previous lessons. Additionally, grading styles and criteria are managed in the Setting tab where you can control how grading is displayed and how it behaves. At this stage, grading should be understood as a system rather than a tool. Grading starts from a footprint, follows a set of criteria, and extends toward a target to create a design surface. It's controlled by feature lines, organized into grading groups, and used to generate surfaces and compute volumes. Thank you for watching. See you in next lesson.